So welcome so much. We want to look on the polynomial functions. Polynomial function is a function defined by fx equals to a1 x power n plus a2 x power n minus 1 plus a3 x power n minus 2 up to an x power 0. We know very well that x power 0 is 1, so this last term is usually a constant. So here the a's are our coefficients and n is the order of the polynomial. So we classify the polynomials according to their order. We have the first order polynomial given by this form. This is usually a linear function. The second order polynomial is usually of the form a1x squared plus a2x plus a3, and this is a quadratic function. Third order polynomial is given by fx equals to a2x cubed plus a2x squared plus a3x plus a4, and this is usually a cubic function. Then we have higher order polynomials, and those polynomials of the order above 3. But usually we classify higher order polynomials to be those polynomials of the order of greater or equal to 3. So cubic functions are normally classified as higher order polynomials. So we want to solve the polynomial functions. So we are going to start with quadratic function. So we want to start off by quadratic functions. So as we had said earlier, quadratic function is a function of the second order, or that's a polynomial of the second order written in this form. So it is also presented in this form: fx equals to ax squared bx plus c, where a is the coefficient of the square of x, b is the coefficient of x, and c is the constant. So we want to solve quadratic functions or quadratic equations, and there are 3 methods of solving quadratic equations. The first method is the method of factorization. The second method is the method of completing the square. This is the method of completing the square. The third method is the method of the quadratic formula. The method of the quadratic formula and the method of the completing square, they are similar. So we are going to see this as we are going to learn them. So let us start. With the method of factorization. In the method of factorization, we are going to find two factors. We are going to find two factors, f1 and f2. We are going to find these two factors, f1 and f2, such that the sum of these factors is b, and the product of these factors is the product of a and c. So we are going to find these two factors whose sum is b and whose product is the product of a and c. So let us go directly to illustrate this by the use of, for example, we want to solve this quadratic equation. So the sum of our factors will be 11, and the product of our factors should be the product of a and c, which is 28. Clearly, these factors are 7 and 4. Then now we split the second term, that is b. We now split it into these factors. We now write our expression in this form, such that the second term is retained, and now we have written in the form of the factors. After this, we factor out each pair. After factoring out each pair, this is what we get. Here x is the common term, and here 4 is the common term. So after factoring out, then now we factor out this equation. Then now we factor out the entire equation, and it becomes of this form. So we know very well that for a product of two numbers to be 0, there should be a condition that either one of the numbers is 0 or both of them are 0. So therefore, either x plus 4 is 0 or x plus 7 is 0. That is the condition. So after there, we find two values of x, which are -4 and -7. And so our value of x1, 4, 2, So this one, if you substitute these values in the equation, they just satisfies the equation. So the values -4 and -7 are called the roots of the quadratic equation or function. And therefore you should realize that the order of a polynomial is equal to the number of the roots of that polynomial. So that is the method of factorization. We want to go to the second method, and that is the method of the completing square. Before we get to the method of the completing square, let us have one example that has the coefficient of x squared being more than 1. Here we have an example in which the coefficient of x squared is 3. So we want to solve this using the method of factorization. So the sum of our factors should be 14. The product of our factors should be the product of A and C. That is 24. So therefore it is clear that these factors are 12 and 2. Yeah, because if you add 12 and 2, add 14, if you multiply you get 24. So therefore we follow the same procedure as in the first example. So we split the second term into the sum of the factors, such that we now factorize each pair. After factorizing each pair, we have now this equation. Then this term is equal to this term. Then now we factor out the entire equation. Then this is what we find. And now our condition is that either of the numbers is 0. It is either 3x plus 2 is 0 or x plus 4 is 0. So therefore the value of our x1 is negative 2 over 3 and the value of our x2 is negative 4. So these are the roots of this equation. So by that we are now well equipped with the factorization method. Now let us move to the second method of solving quadratic equation, and that is the method. The second method is the method of completing the square. In this first method, that's the method of factorization, we were dealing with those quadratic expressions that can be easily or that can be reduced into finite factors. Here in the method of completing the square, I want to deal with those quadratic expressions that cannot be reduced into factors. And you can be able to test whether a quadratic equation can be reduced to its factors or not. And this is the test. We now test a quadratic equation by this formula. If you have the square of b, and for them it's the product of a and c, and then you find the difference, you find the number k. If the number k is a square number, then that equation can be reduced into simple factors, and therefore the method 1 can be used. But if we have a k that is not a square number, then it would be difficult for one to use the factorization method, and therefore we will be required to make k to be a square. That is why we call it completing the square. That is the process of making the number to be a square, so that you can be able to simplify the equation. So therefore let us work using an example. So you have this equation that we want to solve. So for you to determine which method to use, then you need to carry out the test to find out whether the equation can be reduced into simple factors or not. So let us carry out the test. Our b is negative 6, our a is 1, and our c is 4. By substituting, we get 6 squared minus 4 times 1 times negative 4, and then we have 52. Now because 52 is not a square number, and here we mean a perfect square, because actually every number is a square, but now we need this number k to be a perfect square. The other number that is a square of a number integer, it should be a square of an integer or of a real number. So therefore, because we have proved that our equation is impossible to be reduced into simple factors, then the only method we can use to solve this equation is the method of the completing the square. So let us then move on to the method of the completing the square. So here we take the constant c to the right hand side so that we remain with this equation. So we want to make this equation to be and a quadratic equation that can be simplified into simple factors. So therefore, for us to add this equation being factorized to simple factors, then we need to add the half b, the square of half b to the both sides of the equation. That is the first step. So clearly we have it this way. So therefore, yeah, if you look this equation, this is a quadratic equation that can be factorized to be x is 3 square. So therefore, x minus 3 square equals to 13. So therefore, taking the square root of both sides, then x minus 3 would be the positive or the negative square root of 13. So therefore, our x would be 3. Yeah, because of the signs, we will have two values of x. Our x1 will be 3 plus the root of 13, and our x2 will be 3 minus the root of 13. Therefore, this will be the values of x. So the first value is 6.06 and the second is 0.606. So basically this is the method of the completing square. This is used to solve equations that cannot be solved or cannot be factorized into simple factors. So we want to move on to the method of using the quadratic formula, and that is the third method. So the third method is the method of the quadratic formula. It is basically built from the method of the completing square. So therefore we are going to have the general expression of a quadratic function. So we want to find the values of x by this function, and at the end of it, or we would have derived the quadratic formula. So therefore, the first step is to take the constant c to the other side. So it will be x squared. Then we add the square of the half of b to the both sides. Shall be a. Be this way. So then we ensure that the coefficient of x squared is 1. So therefore, we are going to divide the constant a, the coefficient a, by all the term. So a by a divided by a divided by a by a. So this one shall be a squared. This a squared. This we should have done up here. So that is the right procedure. Then we now have our equation x. So the equation on the left side can be simplified into a simple factor, that is x b and a, and this will be equal to, here now we find the sum. So the LCM is for a squared, so it will be squared for a. So therefore, by finding the square roots of both terms, we have this expression. Then now the expression in terms of x, we have this expression. So by finding the square root of the denominator, here it is equal to a. So therefore we can combine the equation to be. So by this we have now developed our quadratic formula. This is the quadratic formula. This is used to find the roots of a quadratic function that cannot be factorized into simple factors. So that is why it is used in the same way like the method of the completing the square. So therefore we are going to use an example to illustrate. So this is it. We are going to solve this equation. So we want to carry out our test. So let me try. is 9 minus 2. This becomes 41. And then 41 is not a square number. So then the method preferably to be used is the method of the quadratic formula. That is the method built from the method of completing the square. So then in this equation, our A is 2, our B is negative 3, and our C is negative 4. By substituting these values in the quadratic formula, then we are going to have two values of x that are, so we are going to have these values of x. Either x is this or x is this. That is the values of x. So that is the method of the quadratic formula. So by those three methods, one can be able to solve any quadratic equation or any quadratic